Hello everyone. In this video, we will briefly introduce two mortality laws, the Coombs law and Mencken's law. Coombs law, the force of mortality has a form B times C to the power X, where B and C are constant. You can use this force of mortality, use the definition to obtain TPX. TPX has the form the exponent minus B over natural log of C times C to the power X times C to the power T minus 1. The other mortality law, Mencken's law, introduced an additional constant to the force of mortality as compared to the Coombs law. The force of mortality of Mencken's law is A plus B times C to the power X. This additional constant A to the force of mortality is used to model the additional risk of accidental death. This term has a larger impact at younger age. The TPX has the form the exponent of minus A times T and then minus B over lateral of C, C to the power X, C to the power T minus 1. If you are taking the SOA exam, you don't need to memorize all these formulas. The formulas are given in the table. This is for Mencken's law, and for Coombs law, you simply set A equals 0. Let's take a look at two examples how you can see Coombs law and Mencken's law in the exam. The first example, you are given that mortality follows Coombs law with B equals 0.00015 and C is 1.12, and you are asked to find the density function F40 at 15. All right, we have the formula for Mencken's law. Coombs law, we set A equals 0. And then we are given the value of B and C. To get the density function, we need the TPX times mu x plus T. TPX and mu x plus T, the formulas are given. So we need to get 15P40 and mu of 40 plus 15. We need to get mu 55. We get B and C. A is 0. So substitute into the formula, and then we get the value for mu 55. 15P40, be careful of the value of X and T when you are doing the substitution in the formula. All right, so this is the expression. The first term, B over lateral of C, and then C to the power X, X is 40. And then the last term, C to the power T, T is 15. Upon calculation, we get the value for 15P40, and then multiply these two numbers to get the density function F40 at 15. All right, let's take a look at another example. Mortality follows Coombs law for a life at age 30, given that mu 30 is 0.0005 and mu 40 is 0.0015. And we are asked to calculate the value of 25P30. For Coombs law, A equals 0 under the Mencken's law. And we only have two unknowns. We need to determine the value for B and C. So we are given two different values for the force of mortality, and it is sufficient for us to get the value of B and C. All right, mu 30 equals B times C to the power 30, and then mu 40 is B times C to the power 40. Two equations, two unknowns. We can solve for the value of B and C. We get the value for C and then the value for B here. To get 25p30, we already obtained B and C, and A is 0. Then the rest is simply substitution. 25p30. So substitute x30 and t is 25. Upon calculation, we get 25p30 is 0.9358. That's it for today's video. Thank you for watching and see you in the next video.